series. Hopefully everyone watching this has already watched one of our first 2 sessions on opening a .text file and storing the data from that file into a Python dictionary. If you had technical difficulties during either of those 2 sessions, hopefully you set up a meeting and we worked through them together before you are now watching this tutorial live or after the fact. So before we begin, I need to review our code of conduct. Again, just a reminder, by joining this Zoom call and participating in this tutorial seminar series, you have agreed to adopt these values and engage in respectful communication only. If we see any inappropriate remarks in the chat, you will be removed. Get all of the comments are on the website, which someone from the Xdev team will post in the chat. So feel free to refer to that, follow along as we move through the content. And I also want to remind you of your 2 most precious Python learning resources, Stack Overflow and the Python documentation. And again, this seminar is also only 1 hour long. So if you have any trouble, please just sit back and relax and we will help you after the fact. We cannot stop the lecture to give individualized attention. You might be able to get some help in the chat and we will have time for questions afterwards. Today, we're going to be learning about basic math operators and write our function to compute win-chill index. So here on the slides, you can see a link to where we got this formula from that hopefully someone can copy into the chat. And we are going to calculate wind-chill index. So WCI here is our wind chill, and we're calculating it in degrees Fahrenheit and using wind speed in miles per hour. And then we've got 4 other constants here that we'll show them again when you need to write them up. So we are going to pick up where we left off 2 weeks ago. So to review, I'm going to open up a terminal and you should do the same. Okay, I am now on my terminal. To review, let's see what we have in there. So I'm going to move into it, into our folder for this Python tutorial, and do an ls to see what we have so far. Now you can see that we have our data folder and our mysci.py folder. We also have our corresponding Git repository and Conda environment, which I'm going to go ahead and activate now with Conda activate Python_tutorial. Now, just a tip, if you forgot what you named your tutorial, at any point you can do Conda env list, and it'll list all of the Python environments that you have. So I recently cleared out all of the environments for my other projects, and I just have 3: base, the tutorial with this little star that shows it's what I'm currently in, and my Xdev project one. So you probably just have these first 2 unless you've been in other Python tutorials for this. Okay, so now let's open up our script. I'm going to use Nano. You can use whichever text editor you prefer. And we see that you've created your columns dictionary and our types dictionary that we then use to generate our data dictionary and fill it up as we read in our data file. Hopefully yours looks like this. We've read this data in a way that's easy to modify. We never have to come in here and change this for loop. We only have to change this beginning part here, which we have to do now. So in order to calculate wind chill index, as you saw, we needed temperature and wind speed. So first, we're going to have to add that to our columns and types. But even before that, let's actually go in here and print the header of our file again, so that way we can see which index wind speed is. So I'm going to go ahead and call this header line equals datafile.readline within the for loop with the comment above it that says read the first 3 lines or the header. And then I'm also going to print header line. So this shouldn't change any of the mechanics of our function at all. It's just going to print out the header for us when we execute it. I'll leave this up for a second more. And again, the only purpose of this is so we can count how many columns over our wind speed is. Okay. And I execute with Python mysci.py. Okay, so you can see that we have our first line that's printed out, our second, and then our third that is all dashes. So we can actually count over to wind speed with, you can see we've got 3 winds in a row printed from our first line, but one of them speed, one of them's direction, and one of them is run. So date is 1, time 2, 3, 4, 5, 6, 7, 8. But that is actually index 7 because if you remember, Python is 0 indexed. So we're going to go back into our script. I'm going to clear this and edit the script. Delete this header printing because again we don't need that. We just needed to figure out what our index was, and some of you might have liked to see that instead of me just telling you it's 7. Okay, so come back up to the top and we're going to edit our columns and our types dictionary to include wind speed. So what that looks like is after temp out maps to index 2, comma, space, wind speed, maps to index 7. And we also have to add it to our types dictionary, comma, wind speed is a float. So that's all the changes we're going to make right now. Before we're going to go ahead and do a git add for this, but I'll leave this up for a second more. Okay. Save your changes, and we're going to do a git add mysci.py. Now, again, just a reminder, if for some reason you were having trouble with Git or just plain not interested in it, you can skip all the Git steps in the tutorial and just follow along with the pure Python, but we do encourage you to use Git. At the end of today's tutorial, we'll be pushing our local Git repository up to GitHub, and that's a very useful tool that, again, will only make sense if you have been following along, but if for whatever reason you're having issues with the Git commands, just don't worry about them. So git add, and then a git commit. -m for message, and we're going to say that we are reading wind speed in 2, or a similar message that you like. Okay. Now we're going to go over Python math operators, because we will need to use them in order to write a function that does a calculation. But the easiest way that the Xdev team and I decided to do this was, instead of going into our script, you're just going to type Python into your terminal. And that's going to open up kind of a command line interface for purely Python commands. And we're just going to show you some basic math operators that should look familiar from your previous language. So again, addition is just your plus sign. Subtraction is your minus sign. Division and multiplication is asterisk. for multiplication. We also have integer division. So say I wanted to do 5 divided by 2. And if you do 2 backslashes, you will get 2. So it takes the largest integer that you can divide your value for. And if you want to find out the remainder of what's left, you actually do the percent sign. So 5 divided by 2 is 2 remainder 1, or 2.5. This could be useful for certain purposes. And another math operator we're going to use today is actually the double asterisk. So if you do 5, 2 asterisks, and then a 2, this is an exponential, so you'll be raising it to the second power. So we get 25. Okay, so that's all the little Python math we're going to show you here. To get out of the screen, you type exit, open close parentheses, like a Python command. And now you can see I'm back in kind of my normal terminal space. Okay, so now we're going to go in and write our function. I'm going to clear this, open up my function, and we're going to go and add our function to the bottom of our file. So again, past the 2 dictionaries we just changed. Nothing else needs to be changed because we did a good job refactoring our code 2 weeks ago. And now we're going to add a comment to indicate what we're doing. We are going to compute the wind chill temperature. And now we're going to start our function. So in Python, you type def, which is short for define, and then you put the name of your function. First, it's going to be compute wind chill. It's always best practice to name your function a verb that describes what it is your function actually does. So if we're computing wind chill, you name it compute wind chill. It wouldn't really be a good idea to just name your function wind chill, even if that feels like it makes some sense, because I mean that's a noun and kind of a sensible name for the value that your function returns. So just kind of to avoid future confusion and make it easier for you to read through the script and know exactly what it's doing, we are very pro verb here. So after we define our function name, we're going to open and close parentheses, and inside of our parentheses we put our input arguments for the function. So first we're going to use temperature and wind speed, which we'll just do a T for temperature and a V for wind speed. Separate them by a column, by a comma, and then do a colon to end your line. The preceding lines of our function are going to be indented by 4 spaces, just like in our for loops. So go in a line, add 4 spaces, and we're just going to first define the 4 constants that you might remember from the slide. So A, B, C, and D. I'm going to give you a second to make sure you get the numbers down right. So 35.74 is equal to A. B is 0.6215. C is equal to 35.75. And D is equal to 0.4275. I'll give you a second to get these numbers down. This equation for wind chill that we're using is more of a best fit curve, so there isn't necessarily a strong physical meaning to any of these numbers that I know of. They just had a good regression. They just happen to work best. Okay, so now we are going to create a new variable that we're going to call V16, since in our wind chill formula, our wind speed is raised to the 0.16th formula, or 0.16th power. So you set V16 equal to V, and then double asterisk to raise it to the power we want to. And then we're going to go ahead and write our function, or write our math equation within our function to compute it. So WCI for wind chill index is A plus V times T minus C times V16 plus D times T times V16. Again, with T being temperature and V16 being our wind speed to the 0.16th power. The parentheses here just follow our normal order of operations, and it looks like they wouldn't actually be strictly necessary, but it makes it a lot easier for us to read what this equation is doing. And then we are going to return our value, WCI. So that looks like the word return, and then the name of the variable we want to have available to us outside of the function. So basically everything that's defined while indented inside the function only exists inside the function scope, and therefore is only accessible inside the function. So if in a few lines later I wanted to call up this variable A, I would not be able to do that if I was in the rest of my code, like the main body, instead of in this function. And anything you want available outside, you need to be returning. So we're not calling up any of these variables again, except our final calculation. We don't really need them. Sometimes it might be tempting for people to define these variables outside of their function to then call them up in their function, but that's not recommended. Again, we want you to use this local scope. This has the advantage of making your function self-contained. So anything in it depends upon the arguments that are passed into it, no global variables. Okay, guys, I'll give you guys one more second to have your function written. Again, noting the syntax of the def space name, inputs in parentheses and the colon, the indent, and the return value. Okay. So in order to actually call up this function, we're going to first introduce you to a different Python function called zip. And we're going to demonstrate how to use that first. So zip is like a zipper. If we give it two lists, it'll match the first element of both lists together and the second and all the nth elements until the end. To demonstrate this, we're going to use a for loop with two iterators, one corresponding to each list we want to move through. So this is going to look like, first let me just specify that this is a debug section and not going to be strictly part of our code. So we're going to say for I comma j in. So you'll already see that this is our first time having two iterators in a for loop. They're separated by a comma. And instead of passing in a single list, we're going to pass in a zipper of the two lists that we want to loop through, I looping through the first list and j looping through the second. So we're going to say zip, which is our function, and open close parentheses, and it has, right now it has two input arguments, the two lists we want to zip. So one is going to be just 1, 2, and we're going to call the second one, it's going to be 3, 4, 5. We're going to make them different lengths just to see what will happen. Four spaces, and we're going to print these two values. so that you can kind of see how the zipper works. You could pass in as many arguments as you want into zip, as long as they're all lists here. Okay, I'm going to exit this and run the code. Okay, so you can see when we first looped through it, I and j were equal to 1 and 3 respectively, and then 2 and 4. So the first element from both lists and then the second element from both lists. And then zip automatically is like, we don't care about the remaining indices of one list that might be longer than the other that was passed in. This zip function, it creates a zip object, which is actually a tuple, which you can think of as being like a list, but it is not changeable. I couldn't go in and edit any of the values, which makes it a lot faster for Python to access it. So let's go in and delete that example and actually replace it with looping through our temperature and wind speed to compute our wind chill index. Okay, so this was down at the bottom. Here we pass our function, and this is no longer, we're no longer going to call it debug. We're calling it computing, or like running the function to compute wind chill index. Okay, so the first thing we're going to do is initialize wind chill as an empty list, which is again open close square brackets. And then in our for statement, we are looping through temperature and wind speed in our zipped object. Our inputs for this are going to be two lists. The first list being our temperature, which we get from our data dictionary. So data temp out. The second list we're going to use in our zip is wind speed. Okay, so we have essentially this is the same as for I, comma j in zip, list 1, list 2, but our lists happen to be accessed through our data dictionary. Okay, so then within our for loop, 1, 2, 3, 4 spaces, we're going to append our wind chill list with windchill.append. And what we are adding to the list after every time we've looped through the function is the output from wind chill, from compute wind chill, which has the inputs temp and wind speed, mapping to T and V. And don't forget to close the parentheses. You have two now from running your function with its inputs and the append. So again, what's happening in this for loop is every time we we go through a new iteration, our values of temp and wind speed are the next value down from our lists of data from our data dictionary. And then those new values are used as the input for our new function call. So we call the function once every time we run through the loop, and then we add that to our new list. Okay, and now we're going to add a debug section where we just print out wind chill. To see that it worked. Okay, I'm going to leave this, execute it. And oh boy, you can see we have a really long list of wind chill values. Okay, which I definitely have to clear before we move forward. So if you had an error there, it could be within your function. If there was an error in your function before, since it was never called, it would only show up now that we're actually calling the function. So hopefully you have a second to debug and figure all that out, while the rest of us are going to do our Git staging and committing. So Git add your file, Git commit -m, and then our commit message. So we are compute wind chill factor is a good message for what we've just done. Okay. So now it just so happens that our wind chill factor was actually in our data file originally, so we can go and read that in and compare it to our calculated values. To do this, we're going to go and pull it up. If you want to figure out the index, again, you could print the lines of the header, but for simplicity, I'm just going to go ahead and tell you that it's index 7. I'm going to open up my script, and we're going to edit columns and types once more. So now after wind speed, we go in here, and we're going to add, we're going to call it wind chill. And it maps to index 12. And we also want it to be a float instead of a string. So we add it to our type section. I see I have a typo up here. I used the apostrophe instead of the, or I don't know the technical difference between those two, what they're called. I don't remember right now, but just make sure you're consistent. Okay. So now we're going to go into our debug section, and we are going to print out the calculated value, the value from the data file, and the difference between the two. So go ahead and scroll down to the bottom of your script, which is getting a little bit longer. Pass your function call. And now in here, instead of printing wind chill, we are going to do one more for loop with a zip in it.
Julia?
Yeah?
There have been some people who have noticed an error. Could you go up to the top of the file?
Yep.
You have the type for wind chill set to 12, not float.
Oh. Thank you,
Good catches, everybody.
I said float, but I betrayed myself when I typed. Yes, we want to set it to float. 12 is not a type. Okay, so we are going to do our loop for printing. So we are going to loop through, we're going to call it wind chill underscore data for the wind chill from the data file, and wind chill comp for the wind chill that's been computed. And we're going to put this, or loop through the zipped two lists. If you can guess, our first list is from our data dictionary. So it's the wind chill from there. The second list is the list we just generated from computing the wind chill index. And within our for loop, we're going to print, and then we're going to use F string formatting. So you do print F, and then if you do two parentheses or two apostrophes, everything within these two apostrophes is going to be F string formatted. That allows you to kind of manipulate how you want your floats to be printed. So each object is going to be inside these curly brackets, our first one being wind chill data from the data file. We're going to type that value and then :.5f. When you do this, .number f, it specifies how many values you want printed after the decimal point. This may be familiar from some of your other languages that you've coded in before. Some use this, some don't. It's very useful, but also, you know, can be slightly confusing. If you forget how to do something, it's easy to just look up exactly that method instead of trying to memorize it all. So we're going to print this to 5 decimal points. We're also going to print our computed data to 5 decimal points. And we're going to print the difference between the two, data minus comp, also to 5 decimal points. So this allows you to know the accuracy of your print statement. We don't need 12 decimal points. That's just going to be visually a lot. So this is all we're going to do right now. We're going to go ahead and run it. And make sure you've closed the parenthesis in your print statement. Okay, so you can see that we have our data from the file here. Like for the last time step is 61.7. For the first one is for the computed value is 64.3, and the difference between that is 3 degrees. You can see up here we have kind of larger values that are maybe alarming, such as 11. For the most part, it's somewhat low differences, but also if you remember the formula we used, the fit between wind chill index, wind speed, and temperature is actually only accurate for temperatures below 45 degrees Fahrenheit. So it's not that surprising that our fit isn't the best right now. We're just kind of using this as an example to show you how to write functions. And maybe if you want practice, you can go in and change the function to be something a little bit more accurate for data in this range. But again, as someone pointed out, maybe you don't even really talk about wind chill when it's this warm out. But we hope that it's still a useful learning example. So,
Julia, we've had a question that I think could be clarified by just showing the bottom of the script.
Yep. What's the question?
It says the WC underscore things are not defined. How does Python know what they refer to? And you can see they're defined in the for loop, in the definition of the for state, after the for statement.
So it's just like your iterator of for I, comma, j. Each time it's sort of like redefined and carries a new value. So WC underscore data is set to the first element of our wind chill list from our data dictionary. WC comp is the first element from our wind chill list. And then the next loop, they're the second element, the third, and so on. I hope that makes sense. Okay. We are going to do our Git Add and Commit right now. Git commit, our message will be compare wind chill factors. Okay, we're now going to go into our file and we're going to just kind of change the printing of the output to make it a little bit nicer to read. So first, let's go in to our script again. And down here at the bottom, we're gonna delete this debug section. We're gonna rewrite this print statement a little differently. And instead of just calling it a typical debug section, this is gonna stay around. We want this, it's gonna be the output comparison of data. So instead of defining our zip object in the loop, since for this one, our zip object is actually going to be rather long, we're going to define it first. So we're going to do zip data equals zip. And then within the parentheses, we're going to put in 4 different lists. So the first one we're going to print is our date list from the data dictionary. We also want our time list, our original wind chill, and our computed wind chill, which is a list not from the dictionary. So now we can go into our for loop and say for date, time, original wind chill, computed wind chill in zip data. See, it's a little cleaner. That line would have been very long if it was all together. And now we are using 4 different iterators, each corresponding to the 4 lists in our zip object. We're going to first calculate wind chill difference. Okay, before we calculated it in our print statement as well, but this is a little nicer again because our print statement is going to be longer. And we are going to then print with some F formatting. We're going to do our date value, our time, and we are going to do this greater than 6 value. This means that we want our time printed object to take up 6 characters and be right justified, no matter how long it actually is. So this way, when we're at 1 o'clock, it takes up the same amount of space as when we're at 10 o'clock. It'll just pad it with a space to the left when we have 1 less number. We're gonna do our original wind chill. And just to kind of show you a different F-string formatting method again, we're going to do 9.6F. So that means that we want the printing of the original wind chill to take up 9 characters with 6 of them after the decimal point, as before. So 2 before, 1 being the decimal point, and 6 after. We're going to do our wind chill comp also to the same accuracy. And our wind chill difference. We're gonna make this one an extra space, just in case. Okay, close the F string and then close the print statement.
You have a parentheses there instead of a curly bracket.
Thank you. Okay. Does everyone see that? So we're also going to add a header to this. We're going to go ahead and print a header. So the first thing we're going to do to make sure we get all the spaces right is we're going to print and then a string with just dashes. So we know that our data, when that prints, it's actually going to take up 7 spaces. So I'm going to add 7 dashes for that. Then a space. Time, we set it to equal 6 spaces. So 1, 2, 3, 4, 5, 6. We set the next 2 to be equal to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, space. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's what we're going to print to kind of separate our header from our data. And now to print the header, we have 2 more lines we'd like to print. We're going to have a 3-line header, just like in our data file. So first we're going to print. Okay, you need 1 space and then the word date, and then 2 spaces. And then we do a space to be lined up with where the time is going to start printing, which, because that's 6 spaces and time is only 4 characters, do 1 more space, time, space, a space to get to wind chill. Just type wind chill, space. This is also a wind chill value, and this is the difference. So you can see that nicely lines up. It's the same number of characters. Okay, and then we need to specify the difference between the 2 wind chills in a print statement above it. So we're going to do 7 spaces to get past date, to get past time, and then we're going to add a little clarifying statement. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And then we're going to write that this one is the original, which is 1 letter short. So we're going to say original there, space, computed. And that's all we got to print there. Okay, so if everyone has their print statements looking like this, I'll leave it up for a second longer. I know it can be a little tricky to get the spaces correct. And if they're not correct on your end, it's really not the end of the world. This is just a pretty way we like to print it, but it's not going to make or break your code. Okay, let's go run it. Okay, so you can see we have our date, our time, wind chill from the file, wind chill we computed, and the difference. And you can scroll all the way up to the top because we printed a lot of different values. That everything is lined up pretty nice, and there's headers to each of the columns that have been printed. And hopefully that looks good to you, or you have something similar. And congratulations, we have now completed our first Python script. I'm gonna clear this again to get to the top. Let's kind of do our Git Add. Again, if you want to have a more accurate wind chill, that's a great homework assignment for you. And we'll kind of go into some other computations and how to organize your functions around during the next session, which will actually be in about 2 months. So again, git add mysci.py, git commit -m, and this time my message is output formatting comparison data. Okay. And now that our script is actually something that actually is doing something instead of just a standard science script, we can rename it to something more indicative of what it is. So do git move with mv, and what we're moving is mysci.py, and we're moving it to windchillconf.py. Oh, excuse me. You could check this again with the git status. So you can see we've renamed this file. So this is, and if we do an ls, we have renamed it here too. So this is like we renamed our file and did a git add on that change. And we'll do a git commit. Renaming our first script. Okay, everybody, we are now going to push this to GitHub. So hopefully, as I sent out in an email a week ago, everyone has created a GitHub login, or you already have one and you have logged in. So I'm going to go ahead and open up a GitHub window. Okay, so this is what GitHub looks like. It'll look a little different on yours if you're a member of different repositories. And what we're going to first do is create a repository. So after you've logged into your account, you see this little plus sign up at the top toolbar. And there's a drop-down menu there, and we're going to click New Repository. We're going to name it. We're going to name it the same name as your local Git. So we're going to call it Python_tutorial. And you can make it private if you like. I'm going to leave mine as public. And I'm just going to go and click Create Repository. Okay. So we're going to copy the link to this repository, which you can actually do with, you see this git at github.com, your username, / the name of it. So copy it right here. There's this little copy button. You can just click it and it's been copied. And we're going to go back into the terminal. Okay, so we're going to add our remote repository. So we do git remote add origin and then paste the link to your GitHub repository. Okay. And then verify it with git remote -v. So that's how you can see that we now have on the website, we have our repository that we are now linked between the two. And finally, we are going to push everything that we have locally in our Git repository up to our GitHub repository. So Git Push origin master. There are definitely some GitHub cheat sheets, and it's good to just kind of learn the specific commands that you need for your workflow that are helpful. Okay. And we now have everything upstream, which is great. Okay.
Julia, would you like to go to the website, show people?
Yes, I was just thinking I would do that.
Okay.
Pull it back up, pull up my website. I think this is what we want. Okay. So if you refresh your repository on the website, you now see that we have our windchillconf.py, which is our script, as it last was, even with this print statement. And we have our data, which you can also click on and look at. And this is organized a lot better than it was when I printed it in my terminal. As you can see, it actually fits the columns to the width of the page. So that's pretty nice. Go back, and you can kind of look at that and see that you have everything up here. Think of GitHub as an online storage version of your project. So this is great if you have to use a different computer for some reason, or your computer dies, and you don't have everything just stored on your hard drive. You want a backup somewhere. So it's kind of like a Google Drive, except it's a lot nicer for code. The fact that it can actually render your .py file and show you what it looks like, even with this syntax highlighting on your for and with statements, and functions are in purple. It's just really nice. So again, think of it like a Google Drive, but with features that are a lot better for coding. GitHub is also really great if you want to work collaboratively. So if you want other scientists to be able to look at your code, or you want to look at other scientists' code, and it easily shows the changes between different files that you've made. So basically, it's really great, and we'll go more into this when we discuss how to work collaboratively and as we build out this, this script. That concludes the first Python script virtual tutorial. You learned to write your first Python script. You calculated wind chill index. You called a function. You learned math operators, the zip command, and the tuple data structure, as well as some f-string formatting commands. And again, we just pushed everything up to GitHub. So we did cover a lot in this hour. And just so everyone knows, we're going to take a break for the holiday and conference season, as like 2 weeks from now is the day before Thanksgiving. And then after that, I know we have a lot of conferences coming up. So we're going to use the same code at the end of January to restructure and reorganize our functions into a Python package. I know a lot of you might not think that you want to publish your code as a Python package, but it actually is really great if you've ever sent any code to another scientist who's doing a similar workflow, and then later on you made some changes and you don't necessarily have a list of everybody who now has an outdated version of your code. This is a really great way of making sure everything is version controlled and everyone knows what version everything's on. And perhaps on an even more fundamental level, it'll help you understand what Python packages are, as they're very integral to your Python workflow. So you're very likely going to start importing other people's work. And we're going to cover the most common Python packages, such as NumPy and matplotlib for plotting, and even Xarray. We're going to start teaching you how to use these other tools that other people have built and bring them into your Python workflow. And hopefully that's a little bit more intuitive after these lessons. So again, thank you everybody, and we'll take questions now.
There's a question about the exact date of the next tutorial. Do we know that? I think it's, is it the last week of January or the 4th week of January? Yes,
so it is January 27th. January 27th. We'll be in 2021 and likely still working from home. And yeah, and we'll have plenty of time to develop and get that material as best as we can for all of you.
There's been a request to see the, wait, there are a lot of things coming in and I'm trying to keep up. Could you show the last 2 commands on your terminal again?
Okay.
Those were the Git commands, I think.
Mm-hmm. Yep, let me just go in and share that screen again. Okay, so I'm going to do a clear to move it up to the top. That's okay with people? And what we typed was, well, I'll do the last 3, I guess. So git remote add origin, and then our link. So we have that.
Right.
Mine failed because I already did that. Git remote -v to verify it, and then git push origin master, which if I run that, it'll also fail because, or it'll give me some sort of message that my local and upstream already match. But so those are the last commands that we ran.
Okay, so some people have had problems. I think if you use the Git syntax, so git at github.com, you need and you decided that it was going to be a private repository. I think you need a SSH key set up on GitHub. So some people are getting some errors associated with that. You can change your repository to be public if you'd like. As Mike Levy points out, if you switch to the HTTPS syntax, it will prompt you for your password, your GitHub password, and then it should remember it the next time you use it. For those of you who put the Git syntax in for your origin, what Julia is showing right now that says git remote -v will print out what the value of origin is for both fetch operations, that is pulling down, and push operations, which is pushing up. You can actually have those two things point to different repositories if you want some crazy situation where you're pulling from one repository and pushing to another. For those of you who have that Git and it's a private repo or something and you want to actually fix that, then what you should do is, and maybe Julia can mimic this in her repository, so we can actually do it, for example. So do
in the terminal?
Yeah, in the terminal, sorry. Git remote remove origin. Go ahead and run that. And now if you do git remote -v, you should see that it says nothing. And then we'll add it back in. So we'll say git remote add origin, but now we're going to use the HTTPS syntax. So https://github.com/jukent/python-tutorial.git. And now you should be able to try doing your Git push and everything should work, I hope. Or at least it should prompt you for your password.
Which mine is still public, so it won't do that.
Yeah. Excellent. People are saying it worked. Fantastic. Cool. So a couple other people mentioned they had a question about an error that they were getting. Robert is saying that he got an error, failed to push some refs. Okay, I'm not sure I can debug that with just the information I've got here. But let me reference some of the errors that some people were getting. Some people were saying that they were getting errors related to a syntax error in the F string in Julia's script when you were executing that. And then we discovered that it was related to Python 2. This is the reason to have a Conda environment associated with all of your Python projects. So, and this is actually part of the reason why Julia named her Conda environment the same as her project directory, so that she knew exactly what Conda environment to activate. If you forget to activate on most Mac machines, you'll use the system default Python, which is Python 2. Python 2 is deprecated now, and there's no more support starting in 2021. I think it's dead. Maybe someone can correct me on that. Maybe it's already deprecated. But Python 2 will essentially no longer be supported. So Python 3, which is what we're teaching you, is the way to go. Python 3 has F strings. Python 2 does not. And that's why some people were seeing the error. But keep in mind that the Conda environment doesn't have anything to do with the actual directory. It's a completely separate thing. It's an environment that you create using Conda to contain all the software that you might want to use for your project, but they're completely separated from each other. And when we get into talking about come the next year, when we start talking about your first Python package, we'll start talking about how you can specify to new users. In other words, people who actually try to download your package and use it, what things they need in their environment in order to get your package to work. We'll talk about how to specify some of those things. But hopefully that clarifies a couple of things. Seth asks, can you associate a Conda environment with a GitHub repo? So, okay, I'm getting a little ahead of myself. This is kind of what I was going to say when we start talking about Python packages. But there are some, when we start defining how to install a package using a built-in Python package called setup tools, you can define how you install the package into another Python environment. And there's a sort of a canonical way of defining what packages your package depends upon. And that's with a file called requirements.txt. You can actually use a properly formatted file called requirements.txt, and you can use that to install all the dependencies that you would need for your project. So if you had, for example, in your Git repo, a file called requirements.txt, other Python users would know that's where I'm going to get all the requirements that I need to run your code. Now, for Conda specifically, you can actually do something kind of like a requirements.txt file, which incidentally is just a list of the packages you need to install, one per line. There's such a thing as a environment.yml or YAML file. And this is a specially formatted file that Conda uses to specify dependencies for a particular project as well. So sometimes you'll see a requirements.txt. In fact, most of the time you should see a requirements.txt. And in some special situations, you may actually find a Conda environment specification file that's labeled something like environment.yml. That's the best way of doing it, but otherwise there's no specific way of saying if I do a git clone of this repository, there's no other way of knowing what environment you'll need or what you'll need in your environment. Okay, there's another question. Where can one find all the commits on GitHub? Perhaps Julia can show that. If you go, you can actually see in the web page a link, complete history of all the commits, if Julia doesn't mind showing that. There we go. While she's doing that, there's a what does Git Push origin master mean? Okay, so Git Push is the command. It's a push command to Git. Origin is the name of the remote, and master is the branch that you want to push. That's essentially your local branch. Okay, so we're sitting in just one branch of our Git repository called master. That's what it defaults to. And we want to push to our remote, which we called origin. And that remote is the GitHub website. So you can see that command is being very explicit. It's saying, I want to push to origin the master branch. And Joe asks, what does origin refer to? I think I kind of answered that, but you can also, if you remember, if you do that git remote -v command, it tells you exactly what origin refers to. Origin is essentially a shortcut name to the URL pointing to GitHub. David, that was interesting. Okay, I'm glad you diagnosed your own problem and fixed it, because I would not have been able to do that myself from what you said. Excellent, I'm glad that worked. Brian says, I thought I would only have a master branch in GitHub, but I also have a main branch, which is default. Ah, okay, so yeah, so this is kind of the problem with the timing of this tutorial. GitHub is in the process of trying to antiquate some of its old, not terribly polite language for things. As Mike says, GitHub is recently starting to switch to using main for the name of its branches, for the main branch instead of master, for what I hope are pretty obvious reasons. And so when you pushed master up, it probably created a master branch. You can do what's called a pull request and pull everything from master into main, and then you can even delete your master branch if you'd like. But that's maybe for another time. I do have intentions going into the future of doing a more detailed Git and GitHub tutorial as well. So maybe I'll answer those questions in that. Okay, Joe says, does this push your entire local Git repository? Can you push only part of your repository? Not easily. Git is designed to be kind of wholesale. You can't, if you don't want to push certain parts, then my advice would be to not commit those to the repository in the first place. It's very, very difficult to, in fact, I would say that in a general manner of speaking, the only way to push a small part of a repository would be to extract only certain parts of the repository and save that to a new repository and then push that up.
We also have what we'll explain in the next sessions, the git ignore file that say you had a large data file that you didn't want pushed, but you need in that repository. You can list those files in a different script.
Yeah. Now, Joe asks as a follow-up, how do you manage multiple projects then? The best way of managing, okay, so I would say that the best way of managing multiple projects, and I assume what you're referring to there is projects that depend upon each other. Is that true? Because if the projects are completely independent from one another, then you would just have different Git repos. And you'd have different GitHub repositories, and everything would just be completely independent from one another. So I'm not sure what you're asking when you say, how do you manage multiple projects? No, we have not defined different Git repos locally yet. You can have as many Git repos on your laptop as you want. They just are represented as different folders in your file space. So you can have lots of different Git checkouts or Git clones, different Git repositories sitting locally, and they can all point to different repositories up on GitHub. Any further questions? Okay. Well, I hope we answered everybody's questions. If we didn't, please send an email to xdev@ucar.edu and reach out for help. And we will be in touch with you about the next tutorial, which will be in 2021. Sorry for all the everything lining up with big conferences and the holidays just makes it impossible. But we will prepare some new content for you, and starting in January, we'll have more tutorials. Everybody thank Julia too. She did a great job.